here we're going to look at how to rotate figures in the coordinate plane. When you rotate a figure, you need to be told 3 pieces of information. One thing you need to be told is how many degrees you're rotating the figure. So we often work in degrees of 90, 180, maybe 270. And so if you picture yourself standing in a room, if you were to turn 90 degrees, you would do a quarter turn. So maybe if you're facing the front wall, you would turn and face the side wall. That would be a 90-degree rotation. But depending on which direction you go, so maybe this is the front of the room, 90 degrees, you're either going to face the side of the room or the other side, and that's going to depend on which way you go. So if I were to go clockwise, following the clock, if I was facing the front, I would now be facing this side of the room. If I were to go counterclockwise, I would be facing the other side of the room. So when I go 90 degrees, it matters which direction I'm going. If I were to go, say, 180 degrees, I would turn twice, and I would end up facing the back of the room. And in this case, it wouldn't matter which direction I went, whether I went clockwise or counterclockwise. So number of degrees, and then which direction you're going, depending on how many degrees that is. The other thing you need to be told is the center of rotation. And so for that, picture like how the Earth spins around its own axis, but then it also spins around the sun. So one of the things we often rotate around is the origin in math. So I want you to picture almost as if we have a lever connected to the origin and maybe to point A. So if you could picture this as like a little swinging arm that's going to swing around the origin here. So I'm going to rotate this triangle 90 degrees, so it's going to be a quarter turn counterclockwise this way, with the center of rotation being the origin. So because I'm going in this direction 90 degrees, I'm going to expect my triangle to end up somewhere over here in quadrant 2. I'm also going to expect as that triangle moves over that it's going to kind of like swing and change a little bit. It's going to rotate itself, so it's almost going to turn like a tiny bit. So there's a formula that we can use for a 90-degree counterclockwise rotation around the origin, and that formula is to take the coordinate xy and to first swap the two numbers, make it yx, and then make that first number its opposite. So what would that look like? That would mean that if someone's coordinates were 2, 1, to make the image, I would first swap, this said 1, 2, I would first swap to make it 2, 1, and then I would make that the opposite. Or if it was 4, -3, first thing I would do is swap those two numbers, so -3, 4, and then I would make the first one its opposite. So I'm going to apply that same thing here to A, B, and C. So point A, that's my pre-image, has coordinates of 2, 2. So to make that into A prime, I'm going to swap, change. And so to plot A prime, I'm going to go -2, 2. And I've got A prime. My pre-image point B is 4, 6. So to make that into B prime, I'm going to first swap and make it negative. So -6, 4. That's my B prime. And then for C, coordinates are 6, 4. So first I'm going to swap 4, 6, and then make the first one negative. And that would be C prime. And then I'm going to connect these with lines. And so I can see how this kind of swung through the origin, and this whole triangle kind of landed on its side. One thing I can do to check for accuracy is, because I went through the origin, is I can connect A to the origin and then its image point A prime to the origin, and I can see that these make a right angle. And if I did that with C to the origin to C prime, if I did that with another color, there would be a right angle there, and I could also do it with B to B prime, as long as I'm going through the origin, because that was my center of rotation. So again, your formula for a 90-degree counterclockwise around the origin is to take the pre-image point xy, swap them, and then make this first number its opposite. So now we're going to do a 180-degree rotation still around the origin. This time we don't have a direction specified, because it won't matter whether we go clockwise counterclockwise or clockwise. If I'm going 180 degrees, it's going to make a 2-quadrant jump. So 1, 2, or if I go this way, 1, 2. So no matter which direction I go, I'm expecting my triangle to end up in quadrant 3. The formula for a 180-degree rotation around the origin is to take the coordinates of the pre-image, x, y, and make them into opposite x, opposite y. So that would mean if my pre-image coordinates are 1, 1, it would become negative 1, 1. Or if my pre-image coordinates were negative 2, 3, it would become 2, negative 3. So whatever these numbers are, we just make them their opposites. If they're positive, make them negative. If they're negative, make them positive. So I'll start with my pre-image point A, and so A prime would be negative 2, negative 2. And that's going to end up in quadrant 3. Coordinates of B, 4, 6. And so image point B prime would be negative 4, negative 6. And pre-image point C is 6, 4. Image point would be negative 6, negative 4. And that would be over here. And then I would connect with lines again. And hopefully what I can see is it's as if I've taken this triangle and completely turned it around in the coordinate plane, so I can kind of see how everything like turned. If I were to spin this original, it would land directly on top of itself. And if I want to check this for accuracy, since I went through the origin, I can connect the origin to A and then the origin to A prime, and I would do that with a ruler if I had it. And what I can see right now is that this actually makes a straight line, which would be my expectation because a straight line has degrees of 180. And if I did the same thing with B to B prime, going through the origin, it would make a straight line. And the same thing with C to C prime. It's just a way to check your accuracy. Again, the formula for 180 degree rotation around the origin, take the pre-image point xy and make it into the image coordinate by doing opposite x, opposite y.